Alright, so today we're going over definite integrals. So definite integrals are just integrals that are bounded by x values, in which let's say we have 2z, the integral of 2z integrated from the x value of 1 to the x value of 2. First we would integrate 2z, in which we would add 1 to the exponent, in which it would be z squared, and then over z, over 2, which is the exponent. In which our integration is going to be just z squared. And now that's got to be integrated from 1 to 2. And in order to do that now with the definite integral, the difference between indefinite is that indefinite integral, you want to plug in the x values that it's bounded by. So in this case, we just plug in 2 squared, and we'd subtract it by 1 squared. And that would give us our rather area under the graph between those x values, which in this case is going to be just 3. So let's take a look at these few questions here. So first, let's get to integrating. Let's look at 27. We have x squared minus 3 integrated from -2 to 3. So first, let's integrate x squared minus 3 in terms of x, in which we would add 1 to the exponent and then divide it by that new exponent. And then minus 3, that would just be 3x. And we don't put a plus c here because this is a definite integral and we're integrating it between numbers. And this is going to be integrated from -2 to 3. All we need to do is plug in the x values here and subtract both things. So we would have 3 cubed over 3 minus 3 times 3, and that would be minus -2 cubed over 3 minus 3 times -2. And in the first parentheses, we're going to have 27 over 3, which is 9, minus, and this is 3, minus 9, which is 0. And then second parentheses, we're going to have -2 cubed, which is going to be -8 over 3. So we're going to have -8 over 3 minus positive, or minus 6, minus -6, which is going to be plus 6. And now we want to distribute this negative, in which we're going to have 8 over 3 minus 6. And we can also convert this 6 as a fraction over 3, in which it would be 18 over 3, because we'd multiply by 3. So our final answer would be -10 over 3. And negative. And now let's move on to number 29. So number 29, we have 8t cubed minus 6t to the -2 power. So when you have fractions, this question is non-fractional form to begin with, but when you do have fractions with the exponent, or rather the variable on the bottom, you want to bring it up to the top and turn the exponent to a negative number. But this is already done for us here. So let's integrate this again. So we're going to have 8t to the 4th power over 4 minus t to the -1 power and over -1, in which both of these would be positive. So we have to integrate 2t to the power of 4, because 8 divided by 4 is 2, plus 6t to -1 power, or we could just write it as 6 over t. And we have to integrate this from 1 to 4. So all we need to do now is just plug it in. So we'll have 4 to the 4th power times 2 plus 6 over 4. And then that would be minus 2 times 1 to the 4th power plus 6 over 1. So on the right, or left side rather, you're going to have 512 plus 1.5. And then on the right side, you're going to have 1 to the power of 4 is going to be 1. So 2 plus 6, which is going to, and if you put that all together, you're going to get an answer of 505.5. So yeah, 505.5 will be your final answer. Now let's take a look at number 30. So we have, for number 30, we have 1 over 8 plus 1 half w plus 1 over 3 w to the 1/3 power. So we're going to integrate that. So we're going to have 1 over 8 w if we integrate that. And then we'll have w squared 1 half times 1 half, which is divided by 2. And then we'll have plus w to the 4/3 power divided by 3 over 4, which is multiplied by, or divided by 4 over 3, which is multiplied by 3 over 4. So we'd multiply that by 3 over 4, and now let's put it all together. So we'll have 1 over 8w plus 1 over 4 w squared plus 3w to the 4/3 power over 12. And we could also just simplify that to 1 over 4. But we're going to integrate this from 0 to 8. So now we're just going to plug in 8 and 0. So if we plug in 8, we're going to have 1 over 8 times 8 plus 8 squared over 4 plus 8 to the 4/3 power over 4. Because 3 over 12, if you simplify, it's 1 over 4. And that would be minus, if you were to plug in 0 into this. But if we plug in 0, we could just see that it's going to be, everything's going to be 0 because there's a variable in each part of this equation. So all we could do is simplify this. So 8 times 1 over 8 is going to be 1, plus 8 squared, which is 64, over 4, which is 16, plus 8 to the power of 4 over 3 is going to be 16 over 4, which is 4. And our final answer is going to be 21. Alright, so I want you guys to try these 3 questions out. So feel free to pause the video and try those out. Alright, so let's take a look at number 32. So we have the definite integral of 1 over x squared minus 4 over x cubed. So all we need to do is just, first, we could actually change this to negative exponents, so it makes it a little bit easier for us. So we're going to have x to the negative 2 power minus 4x to the negative 3 power. And now we could integrate. So if we were to integrate it, we would add 1 to the exponent for the first one, which would be x to the negative 1 power divided by negative 1. And then we have minus x to the negative 2 power and times 4 divided by negative 2, in which both of these would be positive. And now all we need to do is kind of simplify here. So we're going to have negative 1 over x for the first part, because we still have x to the negative 1 power. And then we have plus 2 over x squared for the second part, because 4 over 2 is going to be 2, and then x to the negative 2 power is x squared on the bottom. And now we need to integrate this from 1 to 2. So all we need to do is plug it in. So we're going to have 1 half plus 2 over 2 squared. And then that's going to be minus negative 1 over 1 plus 2 over 1 squared. Now we simplify, so we'll have negative 1 half plus 1 half, which is going to be 0, because 2 squared is 4 and 2 over 4 is a half. And then we'll have 0 minus, actually. So we'll have 0 minus 1, or negative, we have negative 1 over here, and then we have 2 over 1, which is going to be positive 2. So 2 minus 1 is 1, and we have a negative on the outside, so we'll have a final answer of negative 1. And now let's take a look at number 33. So we have the definite integral of 3x squared plus 4x plus 1 over x. So we have a fraction here, and we want to kind of get rid of that fraction and have one long equation. So all we need to do is just divide everything by x, since there's only one variable on the denominator. So if we do that, we're going to have 3x plus 4 plus x to negative 1 power, because it would be 1 over x, but 1 over x is x to negative 1 power. Now all we need to do is just integrate this. So if we integrate it, we're going to have 3x squared over 2 plus 4x. And if we integrate 1 over x, that is going to give us ln of x. Because if you remember, the derivative of ln of x is equal to 1 over x times 1, which is 1 over x. So all we need to do now is just integrate this from 1 to 3. So we could just start plugging in stuff. We're going to have 3 times 3 squared over 2 plus 4 times 3 plus ln 3. And then that's going to be minus, we're going to plug in 1 for here. So we're going to have 3 times 1 squared, which is just 3. 3 over 2 plus 4 plus ln 1. So ln 1. And now all we need to do is simplify all this. So 3 times 3 squared, that's going to be 27 over 2 plus 12 plus ln 3. And then we have minus 3 squared minus 4 because we distribute the negative, and then minus ln 1. But if you remember, ln 1 is equal to just 0, so we're going to have minus 0. So now all we need to do is just simplify all this. So we could combine 27 squared negative 3 squared, which is going to be 24 over 2, which is also 12. So we could write that as 12 plus 12, and then we have minus 4 plus ln 3. And if we simplify it even further, we're going to have an answer of 20 plus ln 3. And that's going to be our definite integral. Alright, so let's go over number 36 now. So we have the definite integral from 0 to 1 of 4 over 1 plus p squared. So we can't exactly integrate this the normal way we've been doing. So if you remember from, I guess, trig or trig functions in calc, so arctan x, or rather, let's write it like this. So let's say you have 1 over a squared plus x squared. That's going to be equal to 1 over a times arctan x over a. So we could see here we have something like that. So let's rewrite it like this. We have 4 of the 4 times the definite integral of 1 over 1 plus p squared dp. And we could remove the 4 and put it on the outside because it's a constant. And we have a squared plus x squared on the bottom, which would be depicted in this case by 1. But 1 squared and 1 are the same number. They're both equal to 1. So we have 1 squared and p squared, which is x squared here. So we can use the arctan here to find the integral. So if we do that, we're going to have 4 times 1 over a. A in this case is going to be 1 for us, which is going to be 1 over 1 arctan x, which is going to be p over 1, which is just p actually. So we're going to have our integral as 4 arctan p. And now we have to integrate this from 0 to 1. So if we integrate 4 arctan p, integrated from 0 to 1, we're going to have 4 arctan 1 minus 4 arctan 0. And now when you put this in the calculator, you want to make sure your calculator's in radians, because 1 and 0 are acting as radians here, not degrees. If you put it in degrees, it's going to give you a totally different answer. So if we plug it into our calculator, we're going to, for arctan 1, we're going to have pi over 4. So we're going to have 4 times pi over 4, and then arctan 0 is going to be 0, so 4 times 0. And now 4 times pi over 4 is going to be pi minus 0, which is going to leave us with the final answer of pi. And that's going to be our definite integral.